The emergency room buzzes. Bright lights glare down from the ceiling above. Machines beep, each one a steady electronic pulse. Life, in its most fragile state, often hangs in the balance here. A patient is wheeled in, their face etched with pain. Doctors and nurses move with practiced, calm efficiency. The medical team suspects a fracture. How can they know for sure what lies beneath the skin? The human eye cannot see through flesh and muscle, but there is a way. A remarkable technology waits. The patient is taken to the X-ray room. The large X-ray machine stands ready, a silent sentinel. A technician explains the process in soothing tones. The patient must remain perfectly still for a moment. A click, a brief exposure to unseen rays. That is all it takes. The X-ray image flashes onto a high-resolution screen. Dark lines on a lighter background tell the story. Doctors can now see the exact nature of the injury. This incredible ability started over a century ago. Our story travels back in time. To the year 1895, we find ourselves in Würzburg, Germany. A physicist named Wilhelm Conrad Röntgen is at work. He is in his laboratory, a place of inquiry and experiment. Röntgen is studying cathode rays, a popular research topic. These rays are streams of electrons in a vacuum tube. He is exploring their properties, their very nature. Little does he know, a profound discovery awaits him.
It was a late evening, November 8th, 1895. My lab was dark, to better observe faint glows. I was working with a Crookes tube, covered in black cardboard. Suddenly, I noticed a faint shimmer nearby. A screen coated with barium platinocyanide was glowing. This screen was several feet away from the tube. The cathode rays themselves should not have reached it. Something new, something unknown was at play here.
Röntgen was a meticulous and careful scientist. He repeated the experiment. The glow appeared again. These mysterious rays could pass through the black cardboard. They could even pass through a book or a block of wood. He held his hand in the path of these unknown rays. The news of Röntgen's discovery spread like wildfire. Imagine the excitement, the sheer wonder of it all. For the first time, humans could see inside the living body. They could do this without the trauma of surgery. Doctors immediately grasped the immense medical potential. It was a revolution in diagnostic medicine, unfolding rapidly. The ability to peer through flesh was a medical dream come true. A new era of understanding the human body had dawned. Early applications of X-rays were dramatic and life-altering. Physicians could now locate broken bones with incredible accuracy. They could find foreign objects lodged within the body. Think of bullets, needles, or swallowed items. Patients and doctors alike were amazed by these shadowgraphs. The unseen became visible, the internal external. It was a marvel, a testament to scientific progress. The diagnostic power of X-rays seemed almost magical. However, this powerful new tool came with hidden dangers. In the early days, no one understood radiation's harmful effects. World War I erupted in 1914. It was a conflict of unprecedented scale. It brought new levels of devastation and injury. This terrible war became an unexpected proving ground for X-rays. The need for rapid diagnosis of battlefield injuries was immense. Soldiers suffered from bullets, shrapnel, and complex fractures. Surgeons desperately needed to know what lay hidden within wounds. X-rays offered a way to guide their life-saving interventions. The technology was still young, but its value became clear. One remarkable figure stands out: Marie Curie. Yes, the same Marie Curie famous for her work on radioactivity. She recognized the critical need for X-rays at the front lines. Curie, with her daughter Irene, championed mobile X-ray units. These were vans equipped with X-ray machines and generators. They became known as Petites Curies or Little Curies.
She tirelessly worked to procure vehicles and equipment. She also trained personnel to operate these vital units.
The impact of these mobile X-ray units was profound. They brought diagnostic capabilities directly to field hospitals. Surgeons could quickly locate shrapnel and bullets in wounded soldiers. Section 5. From Film to Pixels: The Digital Transformation of X-ray Technology. For many decades, X-ray imaging relied on photographic film. Think of those iconic, slightly cumbersome X-ray sheets. The process was similar to traditional photography. X-rays passed through the patient, exposing the film. This film then needed to be developed using chemicals. It was a time-consuming process, requiring a darkroom. The images were static, fixed on the film. Analog technology had served its purpose, but limitations existed. The late 20th century brought a digital revolution. This revolution profoundly transformed X-ray technology. Around the 1970s and 1980s, digital imaging began to emerge. Early digital systems used devices like charge-coupled devices, or CCDs. Later, flat panel detectors became the standard. These detectors could convert X-rays directly into digital signals. This meant images could be viewed almost instantaneously on a screen. The darkroom started to become a relic of the past. The advantages of digital X-rays were numerous and significant. Image acquisition became much faster. No more waiting for film. Section 6. Beyond Bones: The Expanding Spectrum of X-ray Applications. While X-rays are famous for imaging bones, their uses go far beyond. Their ability to penetrate materials opened up diverse fields. Dentistry quickly became a major area for X-ray application. Dentists use X-rays to detect cavities between teeth. They can see impacted wisdom teeth or assess jawbone health. Small targeted X-rays are a routine part of dental checkups. They are vital for maintaining good oral health for millions. A trip to the dentist often involves these revealing rays. X-rays also found powerful applications in industry. Engineers and manufacturers embraced non-destructive testing, or NDT. This means inspecting materials and structures without damaging them. X-rays can reveal internal flaws in metal welds. They can check the integrity of pipelines and engine parts. Quality control in manufacturing relies heavily on X-ray inspection, from tiny electronic components to massive ship hulls. X-rays ensure safety and reliability in countless products. Security is another domain revolutionized by X-rays. Think about airports. Your luggage passes through an X-ray scanner. Section 7. The Modern Marvel X-rays in 21st Century Healthcare and Security. Today, in the 21st century, X-rays are absolutely fundamental. They are a cornerstone of modern medical diagnostics worldwide. Their applications are more varied and sophisticated than ever. From a simple chest X-ray checking for pneumonia, to complex procedures like fluoroscopy, which shows motion. Fluoroscopy allows doctors to see organs functioning in real time. Angiography uses X-rays to visualize blood vessels. These tools are indispensable for countless medical decisions. Specialized X-ray techniques have brought even greater power. Mammography uses low-dose X-rays for breast cancer screening. It has saved countless lives through early detection. Computed tomography, or CT scans, are a marvel of X-ray technology. A CT scanner takes multiple X-ray images from different angles. A computer then combines these to create cross-sectional, three-dimensional views. This provides incredibly detailed images of organs, bones, and tissues. It's like looking at slices of the body without any cutting. Dental X-rays remain crucial for our oral well-being. Routine bite-wing X-rays help your dentist find hidden decay. Section 8. The future is bright and sharper, AI and the next generation of X-rays. The future of X-ray technology looks incredibly exciting. One of the biggest drivers of change is artificial intelligence, or AI. AI algorithms are being trained to analyze X-ray images. They can learn to identify subtle patterns and abnormalities. Sometimes these are things the human eye might miss. AI can flag suspicious areas for radiologists to review. This can lead to earlier and more accurate diagnoses.
Imagine AI as a super-powered assistant for medical professionals. AI in radiology is not about replacing human experts. It is about augmenting their abilities, enhancing their skills. AI can help reduce the workload of busy radiologists. It can speed up the reading of X-rays, especially in emergencies. In underserved areas with few specialists, AI could be a game changer. It could bring high-quality image analysis to remote communities. The goal is to make healthcare more efficient and accessible. AI promises to unlock even more information from each X-ray.
We are also seeing the development of new X-ray hardware. There is a push for more portable X-ray machines. Section 9. A Legacy of Light, the Enduring Impact of Roentgen's Rays. Let's reflect on this incredible journey of discovery. It all began with Wilhelm Röntgen's keen observation in 1895, that unexpected, mysterious glow in his darkened laboratory. From that single moment of serendipity, a new era dawned. An era where the invisible could be made visible. Röntgen's X-rays pierced the veil between the known and unknown. They provided humanity with a profound new way to see, a way to understand ourselves and the world around us. The path of X-ray technology has been one of constant evolution, from those early, wondrous and sometimes dangerous experiments, to its vital role on the battlefields of World War I. Through the development of safer practices and better equipment, the transition from analog film to instant digital images, and its expansion into countless fields beyond medicine, X-rays have consistently proven their value as a tool for diagnosis, for discovery, and for protection. The quest to improve X-ray technology never stops. Scientists and engineers are always pushing the boundaries. They strive to make X-rays safer with lower radiation doses.